And now we move to the next paper. And the title of our next paper is the optimized process for effective decision making to minimize fall from height accidents on construction sites, from Georgia Tech. So please.
Okay.
I'm not sure it
Professor Zhu, can I just share my screen now?
Sure, please go ahead.
Okay. Okay. Does everybody see the screen?
Yes.
Okay, so good afternoon, ladies and gentlemen. I'm Qinghao Zeng, and I'm from Georgia Tech School of Building Construction. And it's a great honor for me today to represent my team here to present our paper, which is entitled The Optimized Process for Effective Decision Makings to Minimize Fall from Height Accidents on Construction Site. So the contents for this paper could be divided into 5 parts, including the problem statement, the research motivation, the research methodology, results and examples, discussion of the results, and at last, conclusions and the future work. So first, let's go through the background and motivation of this research. As we all know that the construction sector within the industrial world is specifically hazardous due to its dynamic and unexpected working conditions. As concluded by numerous researchers, the poor working conditions, direct exposure to the outdoor environment, and also the unexpected change orders are the 3 main contributors to the current situation, which lead to various occupational injuries, especially the fall from height, known as the FFH accidents, concerning falling objects and also the human. According to the statistics from OSHA, in 2021, there are a total of 5,295 FFH cases, serving as the most dangerous occupational injury cause. Consequently, there's an urgent requirement to mitigate the fatal numbers that are caused by FFH accidents by either protecting the workers or anticipating the accidents and prevent them from happening. Okay, so recently numerous approaches have been made to achieve this goal by prospecting a real-time emergency detecting and monitoring system with the aid of several available technologies, including the RFID for detecting and controlling the PPE on site, the UWB ultra-wide band for identifying, tracking, and locating equipment and materials, the GNSS Global Navigation Satellite System for detecting and categorizing and organizing the risk area for workplace, and also the Bluetooth Low Energy BLE beacons for increasing the accuracy and effectiveness for solving safety issues. However, limitations still exist so far due to the uncertainty of device effectiveness, as well as the prerequisites of implementation for some solutions. Therefore, the stakeholders and managers are demonstrating great concern and hesitation of the adaptation of these FFH accidents technologies. So in this research, what is presented is an improved process flow that is aiming at assisting stakeholders with the decision-making process for FFH issues on site by proposing some different solutions to the current limitations, which will be displayed within the flow chart in the section 4. Okay, so as for the research methodology, a systematic literature review is conducted, which consists of 4 steps. First is the determination of the purposes, then is the selection of the database, which is the Web of Science is chosen due to its significant influences on natural science and engineering, and also to select the keywords as fall from height, technology, and accident. And as a result, there are 81 articles that are chosen because of its importance, citation, and also this relevance. And so the final part is review the relevant articles, and all the articles are categorized into 3 subcategories. That is the FFH causal factors, the FFH prevention process, and also the introduction of technological solutions about FFH. Okay, so here's the chart that's showing the result of the literature searching. As we can see, the number of articles is increasing these years, and it reached a peak in 2021. So the total of it is like 81 articles. And so this table displays 6 major literatures along with the reason for selection and why it is under detailed investigation and reviews. And it can also serve as a contribution to the body of the literature review. Okay, so then comes to the third part as the results and examples. So first section is the first subsection for this part is the causal factors and indicators for FFH accidents. As we can see from this table, a total of 5 risk factors are concluded as the possible reasons for increasing number of the FFH accidents, and they are followed by the indicators within each factors, as well as the quantitative variables to construct the criteria for evaluation of the FFH risk level. And that will be assisting the establishment of the conceptual framework for the process model. Okay. And the next slide is the second subsection, which is the cyber infrastructure and system architecture for preventing the FFH accidents. At the figure displayed on the left-hand side, there are 3 major layers in the sensing system, which are the perception and physical detection layer, transmission and computing layer, and service and cyber secure applications layer. So the first layer, the perception and physical detection layer, is responsible for collecting and sending the data about the real-time status information for both workers and workplace conditions. And the transmission and computing layer is responsible for transferring and processing the primitive data into the input data for application layer. And then for the application layer, it is responsible for importing the information and storing them in the cloud environment for both the visualization and the further data analysis. So as for the general procedure of this FFH accident prevention, it's concluded at the 4 steps that's shown in the right-hand side. The first step is to detect the detect and characterize the safety area. Then is to equip the workers with their specific PPE and also the BLE live system. Then is to send warnings to both the workers and management system if there's any emergency happens. The final step is to record the parameters and the hazardous situation, store them in the database in the cloud-based system for the further use. Okay, so in terms of the third subsection, which is the limitations and prerequisites of current system and technologies for FFH protection. The 4 items are under consideration at this part, which are the risk zone identification, categorization, wearable BLE devices, data transfer through Wi-Fi system, and also the computational analysis of worker and workplace data, along with their prerequisites and also the limitations for each items. Okay, so then comes to the discussion of this discussion part of this research. So based on the results from the literature review, problems are reorganized and summarized in terms of each risk items, and along with their potential solutions and potential solutions to each of the problem. The mechanism, the detailed process, and the proof of effectiveness for each solution are based on the relevant researches. So as we can see, for example, in the terms of the risk zone identification, the categorization, it has a problem of, for example, the potential FFH risks are not on building plans. So the potential solutions could be like automatic beam-based FFH identification and planning tool, and that was with the assist of the beam platform. And also for the determination of required beacon number, it can be calculated through simulation on the beam model to determine whether like the number is sufficient or not. Okay, finally, here comes the optimized decision-making process model for minimizing the number of the FFH accidents on construction site. And from the start, it begins at the first stage, as shown in this slide, detecting and categorize safety area and in the workspace. So after that, it comes with the decision-making point. So that is the insight for this research test. We address each limitation to this decision-making point. And so if there's the area detection accuracy happens within that specific space. So if there's like it's not accurate, then we should locating essential coordinates with the GPS and combining with 3D beam model and use the methodology of the K-means clustering for risk areas. So this process model is actually a visualization, visualization way to demonstrate the contents in this table. So if we go through each stages and each decision-making limitations, and after that, it will just come to the end with every potential solution that search with solve the limitations. Okay, so here comes the conclusion part. So as for the last part, this literature review-based research identifies several factors and indicators of the FFH accidents, and also analyze the limitations of the current sensing systems for preventing FFH accidents to the large extent. Also by analyzing the literature's novel process flow for optimization of the decision-making process, for preventing accidents for site managers is proposed, and considering of the future work, we should justify the effectiveness of each solution, validate the effectiveness of the improved system, and in reducing the FFH rates on site, and also investigate the reliability of different integrations and implementations of technology used for the prevention. And finally, conduct the comparison studies in terms of the system implementation expenses between the previous versions and the improved versions. So that's all of my presentation. Thank you all for the listening.
Thank you, Qinghao, and very nice presentation. So any questions for him, for Qinghao, about the presentation? I think this is an interesting topic, right? I mean, construction safety. So.
Yeah, we have one question here.
Mm-hmm.
Okay, please.
Hello, thank you for the presentation. Just one question. How do you plan to do the effectiveness studies between the new and the
So I'm sorry. So you're asking about how to the methodologies or approaches to testify to validate the effectiveness of those technologies or appliances.
Yeah.
So as I just put it on the table, there's some kind of risk items and then potential problems and then some quantifiable data. So like this research is just a conceptual design for all the process work. So for the future research, if we have one specific model, have one specific example, case studies for FFH prevention. So all the quantifiable data is what we need. And so with the also with the help of the comparison case study, there's one that's without those technology and there's one with those technologies. And we just need to collect all the quantifiable data and put it in the model and run the simulation of the FFH prevention. So to see like if there's the fatal preventions or something. But as you can see, it's still it's still on the simulation part. So whether or not the fatality rates will go down, well, it depends. Like it's not specifically it depends on the workers on site. It also depends on the workers on site. If they are not following our instructions, it's like there's warnings sending to their equipment, they're not following it. So there's no way the fatality rates can go down. It's dangerous. So that's what we can do for like effectiveness testing, like through the simulation.
Thank you, Qinghao. And due to the time limit, we have to hurry up and move to the next